Okay, so now that we got all the bases and everything casted up, let's move on to the second part. The first part, if you missed it, we did some lost foam casting where we casted up all these really cool parts with the lost foam casting process. You should check that video out if you haven't seen it. So first we're going to machine this base, and one of the problems that I ran into was, that's right, you guessed it, it's too big to fit in there. But the solution's a little bit easier than you might expect. These jaws can actually come off and go on to the other side of the vise. Now, the key here is to have everything super clean and to clean it twice, because if there's any little bits of burrs or crap in there, it's going to throw off your accuracy a little bit, if not quite a bit. And also for your information, if you're new to this, you can actually do this on the fixed side as well. Now, lots of your machinists are going to tell you that you're supposed to do it on the fixed side and not the movable side. But in the end, this is just a casting that we're doing. Although it is for an accurate thing, the casting's pretty rough, and as long as I don't take it out, I'm not going to have too many problems with this. But, I mean, if you have some suggestions, throw them in the comments down below, and hopefully there'll be some learning as a group. I mean, I've had a lot of really good comments over the years, and a lot of really good ideas that come in from the viewers, and I really do appreciate that. One of the things that I did do is I rushed this job a little bit, and I should have machined this upside down first, rather than running a file over it. In the end, it might have made it sit a little bit more nice on the table, but truth be told, once I put the 3 little feet on the bottom of it, it's going to sit just fine on the workbench, and it'll sit quite level as well, just with the 3 feet. Now the first thing that we're going to do is, we're going to true up this side here of the casting with that sprue that's on the side. And I figured, what better way to do that than grab the biggest 10 mil I have, and mill it all off, giving myself 1/8 of an inch, and then cleaning it up at the end. So the machining process is actually helping us learn a little bit more about the actual casting process. Now, you can probably see a few little inclusions in there, those little hollow marks that kind of wiffle waffle through everything. Essentially, those are gas bubbles that kind of popped up through the whole machining process. Now this casting actually turned out quite well, you know, respectively, since I've had other castings that have turned out really bad. But we'll call that learning and chalk it up for that. Also, what I've noticed with this casting material as well, yes, I know I should be using coolant on this, but the chips seem to stick a little bit more than they would with the regular aluminum kind of from a billet. So I got to be really careful to put some cutting oil on there. Now I know this isn't technically cutting oil, it's tapping oil, but it pretty much works the same. There are other formulas of cutting oil for aluminum, which would probably be a better use, but this is working just fine for what we're working on today. So obviously we're squaring the ends up on this, and as we're cutting through the material, we're kind of finding the underlayer of what we see here. Now, I've got a little bit of a bubble in there, which is actually not a bubble. It's actually kind of like a laminar surface in there. And how this kind of happened here, as we're taking a closer look at it, is the two materials, it's almost think of it like two globs kind of separated into a fork, and then they kind of came back together, and sometimes it'll create either a bubble where the two actual oxidized layers won't stick together, or sometimes it can kind of create little secret cracks that are in there, and they can be quite surprising sometimes if you don't have your casting quite right. I'm pretty confident today though that we nailed this, and this little bit of an inclusion is going to be okay. But in the future, I think we're going to be a little bit more aware of this and try to change a little bit of how we kind of do this and have it flow through a little bit better than what we had today. But that's pretty much the fun of the project, is we basically make mistakes, we learn from them, and it makes us better than we were yesterday. And hopefully tomorrow we can be even better. So the next step in the whole game here is to deck that top surface off. Now we have a few options. I could run that end mill over the top and it would turn out okay, or I could run a 3-inch face mill over the front of it. Now, to be frankly honest, the face mill has some old bits on it, so I've just got to go really slow because one of those teeth is a little bit higher than the other and it can leave little marks on it. So we'll take a final pass on it and make sure we go really slow on it, and it'll be totally fine. There's a bit of learning in here as well. If you're new to machining, one of the things that we need to make sure is, which I've done and you haven't seen, is I made sure that the head, which pivots and turns both front and back, is dialed in to the table. Now, if you're running the face mill and it's off at an angle, you're going to actually dish a little bit on your work. And this is really easy to figure out because as you're cutting, your lead's going to be cutting and your back will be cutting, or your back will be cutting a lot and it won't even be touching anything on the front side. Speaking of cutting a little bit too much on one side, the work's actually cantered here just a little bit due to the casting and probably my sloppy process of bolting it down to the table. And it's only going to cut a little bit on the right hand side, then we're going to mill over on the other side, and it doesn't cut anything. Now let's zero this dial out, bring the table up another 20 or 30 thou, and make the final pass along this. Now, like I said before, this final pass we're going to go on really slow because we want a really good surface finish. Now, if I had a really good face mill, I wouldn't have to go quite as slow as I'm going here because, like I said, all of my teeth would be cutting at the same time exactly, and I'd be leaving a really good surface finish. I think the best solution for this problem here is I'm going to jump on the KBC Tool app and order up a couple more carbide inserts, and then I won't have this problem along in the future. Now, people are probably wondering why I keep bringing up KBC Tools. Well, they're a good company, and I genuinely say that. It's not because they give me a tool allowance and I can make these really cool videos for you with it. They genuinely are. We've probably been servicing with them for about 20 years now, and I really appreciate having the good quality tools show up when I need them and on time. And man, they're just down the road, and they're also across Canada and North America. Now, this turned out quite well, except the only problem that I had here was, well, other than missing the carbides that I'm going to order, is I've got a little bit of a lip on here. Now, this lip here is quite easily fixed with a little hand finishing with one of my files and a little bit of painstaking draw filing. Now, the goal of all this here is to fit this T-slot in through here, and on top of that, this is where our part that we're going to machine later is going to fit on top of this that'll hold the bearings. But first, we need to cut the single slot that goes through here. I wish it was as simple as just kind of running that T-slot cutter through there, but we need to run an end mill through there of the correct size first. And essentially what we're looking for here is a 5/8 end mill. Now, I've chosen to go with a 4 flute end mill here, and later on we're going to find out why that was a bit of a mistake. If you're an experienced machinist, it's probably pretty obvious chip clearance, and we'll talk about that here in a bit. For those of you that don't know anything about chip clearance, it's essentially the room that's going to be able to expel the chips out. And for harder materials, sometimes you use more flutes on an end mill. And for softer materials that you're going to be moving quicker through, you use, well, less flutes, and you can get rid of those chips that are a little bit bigger out of there faster. What we're going to do here first is, because this is a casting, we're not going to get too carried away with exactly, touching off the sides. Is I'm quite literally here just going to bump the end mill up against the side of it, kind of touch it till it cuts a little bit, and then we're going to zero our dial on our DRO. We're going to go over to the other side and touch off on that side as well. Now, it's just a matter of doing a little bit of rough math, and this is a pretty easy one. We're going to divide that in half, then we're going to move our digital readout over to the 1.21, and we're cooking with gas. We're in business. Now, it's just a matter of locking in our cross slides to make sure nothing moves, and we're off to the races. And now what we're going to do is we're going to have a little bit of learning here. Now, keep in mind, learning's really important in our videos here. We're going to move this up 1/4 inch, 250 thou, and we're going to try feeding this in here. Now, I know a lot of machinists out there are probably watching this here that have a lot of experience, and this is where the new guy can do a bit of learning from my mistakes, because I'm not perfect either, right? So what you're going to see here is we're going to feed this in here by hand, and that aluminum is going to start welding to the end mill. Now, if I had had an automatic table feed, I wouldn't have felt this, and I would have broken end mill. I'm even going to try taking a second stab at it, and it's going to become really obvious here, because it's starting to get hard as I'm feeding it into the work, that this just isn't going to work. So what we're going to do here is I'm going to put a misting system on here with compressed air and a little bit of coolant, and we're going to see it night and day change from one side to the other. Now, it doesn't matter that I'm cutting on the left or the right side of this work. It really is relevant. I just started cutting from the other side because I wanted to show you guys that it was going to cut quite a bit better when you use the proper coolant and the proper system on what you're working on. Also, this is a really good time to talk to you guys about the 4 flute end mill that we were talking about earlier. I had tried on a second casting, the one that you didn't see in this video here. I'd actually just buried it right to the bottom. I think it was like 650 thou that I was supposed to cut deep. and I buried it right to the bottom with a 2-flute end mill, and I made a 1 pass on this with a 2-flute end mill and coolant, of course, and it worked quite a bit better than it did with the 4-flute end mill. Now let's measure to see if we're at the right depth, and it looks pretty close to where we need to be. So let's grab that T-slot cutter and let's cut this T-slot into this work. Now the T-slot cutter I got was your plain Jane, very basic T-slot cutter, and because it's aluminum, I mean realistically, not that we could literally use woodworking tools on aluminum, but obviously we're going to use the proper stuff and we're going to do it right the first time. So finding the bottom of this is relatively simple. I mean, our tolerances are probably within 15th thou. So I'm just going to feed the head down by hand just till it touches the surface. And then I'm going to move the material away from it. And then I'm going to add another 5 or 10 thou to the table, bringing it up. And that's going to make sure that we don't have that little groove on the bottom. And it's going to have a nice surface finish as we cut through there. Once we start cutting this here, it's going to be a slower process. So we're going to really want to take our time with this and not rush it. I'm pretty sure trying to cheat out and not use any coolant on this would have really ended in a sad, sad ending. Now, after all that bragging I was doing about using the 4-flute end mill and not breaking it because I was feeling it, and right about now, I'm wishing I did have that power feed for the cross-slide, and I'm pretty sure that I'm going to be saving up that $800 or whatever it is to get a power feed for this table, because this is some pretty painstaking work. It's leaving me alone to have a lot of thoughts on how I got here, and I don't know. Maybe it's a little bit Zen-like. Maybe we're kind of like doing some like milling machine yoga. But either way, we finally made it through to the other side, and everything went according to plan. And I'm pretty happy how that cheap end mill went through. I mean, I'm probably not going to be using that T-slot cutter on any other work in the near future. But it turned out quite well. Now let's slide the T-slots in here and have a quick look how it worked out. It worked out quite well, I think. So the next step that we're going to do here is we're going to drill a hole, and then we're going to bore it for where the post is going to be. Now the post is going to come out of here, will be a 1-inch bar, of course, and it's going to hold all of the dial and adjustable stuff for the top of this whole stand. And of course, this is going to have to be a precision fit, so when we bore it, we're going to have to bore it so that it's an interference fit for the precision ground rod, the 1-inch rod, that's going to go in there. And one of the things that we're going to have to do before we start drilling is we're going to have to lock our table in. All the cross slides on the table are going to have to get locked in so it doesn't start walking around. Now, you guys probably noticed that I didn't use center drill and do all that process, because essentially I can drill and I can be off by up to 65 thou either way if the drill starts to walk, because when I come back and I bore this with the boring head, it's going to bore it directly on center where it originally was. The other thing that you're going to notice here is I'm not going to drill the hole all the way through. Now the reason I'm not drilling it all the way through is not because I'm worried about hitting the table on the other side. It's actually because when I press this bar stock in, I don't want it to go all the way through, and I want it to come to a complete stop. This is more kind of a design thing, and I probably could have had it go all the way through, but it's what I want for the project. Now, let's throw the boring head here in and have a look at this process and talk about it as we go. Like we said a second ago, the table's all locked down, so we should be on center in theory. Now, what we're going to do here is, I'm going to kind of slowly bring it up till the edge of the tool bit starts to cut the edge of the work. And I can tell it's cutting because I'm just going to wiggle the head back and forth a little bit, and then I'll actually see that little line start to develop as it starts to cut, and then I know I'm on size, and then I can raise it up, move it out 10 thou, and take my test cut. And off of that, I can start cutting in to where I need to. It's going to be roughly 65 thou moving in, that's 65 thou off of either side. There's always that radius and diameter thing that you got to watch out for with boring bars. Keep in mind, you're only making a 65 thou cut if you were to take all the material, not a 125 thou cut, right? It's kind of like running on the lathe. Now, I'm probably running a little bit fast here for a boring bar, but honestly, it's about surface finish and I'm taking really light cuts. So once again, we got more learning here. That's right. The tool bit, the shank of the tool bit, is running into the edge of the work, and it's not exactly cutting the way we want it to cut. So we need to grab another tool bit out of the drawer and make sure that we can actually cut to the full depth without that shank, the top part of the tool bit, rubbing on our work. And lucky for me, I've been ahead of the game for a change, and I've got a whole bunch of tool bits that I can pick from, and we can actually carry on with this project. I mean, the other option is to grind a shank off on the grinder, but we've got lots of tool bits, and we're going to use the right one here for a change. Now, let's do a little comparative work here. Now, I've got the longer tool bit in here, and it wasn't quite going to make it to the bottom, but we've got the right one now. Now, one of the other aspects that you have to look at too here is, if this was a precision cut and then I had found out about it, we would have been in trouble. Now, the reason why I say that is because those tool bits it's not like your inserts that you're going to use in your CNC machine with your, car tools. Once you take that boring bar out and put it back in, you're going to have to respec the size of the hole that you're cutting on, which means taking a test cut and adjusting from the new tool bit. And man, I'm pretty happy with the surface finish that I'm getting off of this. It's looking pretty darn good. Let's clean this bore out really good, and we'll have a good look at it and measure, and then we can make our adjustment with our boring bar. And it looks like it's 903 thou, and that's probably not too much of a cut that we got to worry about. So let's adjust this off here, make another couple cuts. And okay, I'm a bit of a scaredy cat, so I'm not going to try taking that total cut all at once. I'm probably going to take about a 30 thou cut, and then I'm going to pull it out, remeasure, and then take my final cut. And keep in mind as well, when you make your adjustments, you're going to be cutting, it's like a lathe operation, right? When you turn the dial, you're actually going to be turning the dial and cutting off half the material, not twice the material. So if you need to take off 60, you need to cut 30, correct? So a lot of people make that mistake, and they try cutting off 60, and they're actually cutting off, say, 120, and they go way oversized, and they only realize their mistake until after they've made the cut. And man, it's probably just about time for a new set of calipers here, but we're going to hang on to these a little bit longer and see if we can get a little bit more life out of them. They're still reasonably accurate, and I can tell this because when I pressed it together, it pressed perfectly together, and it was the right amount of pressure for me to push it together. But we'll get to that a little bit later in the video. So one of the things, if I was doing a bunch of these, I probably could have done, especially because it's a blind hole, I probably could have set up my feed and the stopper for the feed and actually bored it with the machine. Currently right now I'm kind of doing it by hand, and it's kind of a by feel thing, especially on lighter cuts, is to keep that speed going. And then you're going to listen for that little squeal at the end, and then you're going to come back up, and slow as you can. Keep in mind it's cutting on the way back up because of deflection in the tool bit, and it's going to be taking off a little bit more. Usually for me, when I'm doing boring operations like this, the deflection on the way back up is going to take off like, say, 2 or 3 thou, and usually if you plan it that way, it'll turn out just perfect, and you'll be happy with the end result. Happy enough that I'm pretty sure this is going to fit together just perfect when I go to press it in. But there's one more little step that we're going to have to do before we get out there and press that in. And that one more step is drilling a small hole in the bottom of here, because if we don't do that, it's going to hydraulic, and we're going to start having some problems. In other words, we're going to compress the air in the bottom of the hole, and it's not going to be quite what we're looking for, because that's a pretty tight fit we got in there. So we're just going to grab a random bit out of the tool drawer, drill all the way through, and we're off to the races. Let's take this out and have a quick look at it before we press it together and make sure everything's the way we want it to be. Keep in mind, before we press it, that's the time to make sure that everything is going to fit together perfect. Now, if the hole wasn't bored quite proper, or some of that grit was stuck in there, which we're going to clean out, you'd probably have a huge problem on your hands. In other words, it'd increase your tolerances, and it wouldn't quite go together proper. Now, I know I don't really need to do this, but as I was walking out the door, I saw I had some like medium grade Loctite. I'm pretty sure that's what this is. I lost a label on it. And I figured, heck, you know what? It can't hurt to throw some on there as well. And maybe it'll act as a little bit of a lubricant to push it together. And you'll see I'm not actually cheating the system here. I'm not actually gluing it together because I got the hole wrong. I got the hole size right, but I just want to make sure that this is going to stick together. Originally in my plans, I was going to put a set screw in the back there just to hold it in after pressing it in, but I'm pretty sure this is going to be just good enough. And if you're one of the subscribers and you've watched a lot of the videos, you probably recognize that counterweight. Remember that about a year ago we made that in one of our videos? Well, sure, I'm glad we did that because this is working pretty well, and I'm very happy with how this machine's turned out. In fact, I think I'm going to treat this machine next year, and I'm probably going to tear this all down and repaint it, rebuild it, and put it in the actual climatized shop that I have out back. Because I sure do enjoy using this press. Also, this would be a good time to say, hey, if you haven't liked or subscribed, this would be a really good time for that. Because we got a bunch more builds coming down the road, and this is just one of the beginning of them. But I can't show it to you quite yet, because you're going to have to click on the link up on the top left, and that's where the next video is going to be. And you're going to have to check out the cool build where we learn a lot more about casting and machining parts.